Well, good morning, everybody, and welcome to our webinar, variously titled How to Build Your Ideal SOA Infrastructure, or the Impact of SOA on IT. I'm Ian Goldsmith, Vice President of Product Marketing at Soa Software, and this will be a relatively short webinar. It probably won't take much more than a half hour of your time. We want to focus today on what SOA infrastructure is, why you need it, and what it should consist of, a little bit of how to deploy, and a lot of focus around a specific customer example that we're gonna cover in the end, talking about Verizon and how Verizon has benefited from building out SOA infrastructure and what their use case for SOA infrastructure actually is. So without further ado, let's move through the slides. Very briefly, Soa Software is the leading provider of SOA infrastructure. We offer a broad, comprehensive platform. We'll talk more about that. We're the largest specialized vendor of SOA infrastructure technologies. We announced in January that our 2005 revenues were $29.9 million, according to the GAAP accounting standards. We're headquartered actually in Los Angeles, California. We moved offices a few weeks ago, just about a couple of miles down the road, so we can still see the beach from our windows, which is very pleasant. We're very well funded by respected groups of investors, led by Redpoint, and we have an extremely strong portfolio of customers, including Merrill Lynch, Ford, Verizon, a bunch of high-profile organizations. As you can see, here's a list of many of those customers, very strong portfolio. We're very proud of our partnerships. We are a very strong IBM partner with a number of successful joint customers, including Merrill Lynch. IBM has the IBM Global Services SOA management practice is probably the premier SOA consulting organization in the world, and we're very proud to have been the first vendor announced as a partner of that practice, and we remain a very strong IBM partner today. We have also strong relationships within Tivoli and WebSphere. We're also a BEA premier partner, and again we were announced as one of the first partners announced as part of the Aqualogic release. We stood in the closing bell of the NASDAQ with BEA around that announcement. We're a Computer Associates technology partner, a top-tier Oracle partner, part of their Certified Advantage Partner program, and a Microsoft Gold partner, amongst our participation in other partnership programs and various standards bodies. Overall, partnership is a critical route to market for any organization in SOA infrastructure, and we certainly feel that we have the top-tier partners required to succeed. We view the challenge facing enterprise IT as being broken into three distinct groups. We have legacy environments, business-to-business environments, and the world of distributed applications. Legacy clearly is mainframe and other stable technologies that have been around for a long time. B2B is the technologies used to interact with both partners and customers. And then distributed applications, I'm sort of using it as a little bit of a catch-all. That's really where everything else fits. So applications you build yourselves using Java or .NET technologies, your application servers, packaged applications, your ERP and CRM applications from vendors like SAP and Oracle. All of those things fit into that distributed applications bucket. The challenge facing this world is that these are disconnected environments, and the technologies used to connect and integrate them are fragile, inflexible, and expensive. Technologies like EAI for integrating applications, EDI for B2B transactions, and then the custom work that's required, particularly for mainframe to other world integration. The challenge amongst the cost, fragility, and inflexibility that this leaves organizations is that it becomes very difficult for IT and the business to align. If you think about the typical business process change and review cycle, there's normally a drive to complete a business process change within 2 to 3 months. But often the IT change cycle can take upwards of a year, I mean, in many cases more. What this means is that several business change cycles will complete within a single IT change cycle, essentially ensuring that IT is never aligned with the business, is unable to remain in step with the business. So that's where SOA comes in. What SOA does is help an organization reduce cost through reuse, integrate, increase agility, and effectively manage change. So SOA sits at the center of this world. It ties together the various different environments. It helps you integrate your legacy environments with your B2B and your distributed applications. It helps you integrate your distributed applications with B2B. It provides technology for ensuring the standards-based interoperability of applications. It provides you with reusable business functionality, so you can have a piece of business functionality deployed and available in a mainframe that's consumed and leveraged within the distributed environment. The fundamental concepts to think about in SOA, and let's be very clear, SOA is a concept, not a technology. SOA is an architecture, and it's based on the tenets of loose coupling, distribution, standards, and reuse. So I think we often tend to confuse SOA and web services, and while they're certainly related, they're not synonymous. Web services are a technology for a standards-based technology for integrating, for communication between applications, essentially. SOA is an architectural concept around the ability to reuse business services from one application to another. Now, SOA has been around for a long time in one form or another. CORBA and DCOM and some of the older technologies certainly could be considered service-oriented technologies. However, given the proprietary nature of some of those technologies, they really didn't fit into the modern world of SOA, and that's where web services come in. So web services are driving the modern world of SOA by providing the standards-based functionality and ensuring vendor and platform agnosticity with low-cost, flexible architectures. So I think one of the questions that we get asked quite a bit is why SOA? Why should we as an organization move towards SOA, and what's our main driver? Well, I think this statement pretty much says it all. Verizon saved 50% of its IT budget by eliminating redundant systems using SOA technology. That's an absolutely enormous number and an extremely powerful and compelling statement. Now, Verizon's an interesting use case for SOA infrastructure and internal process change to help facilitate and drive SOA. And I'm going to talk a lot more about Verizon as we move on. But for now, let's just leave it with that. So what is the promise of SOA? The promise of SOA is reduced cost, increased agility, through leveraging a standards-based architecture and reuse. The diagram here in the slide is a little small, but essentially it shows the goal. If you can see the new application, in fact, I need to get myself a pointer, which I will do right here. So we can see a new application in this diagram. The new application was 50% new build, you can see the gray pieces, and 50% reuse. These are the transparent pieces. So we have a user login service reused out of Steeple. We have a historical database reused out of Oracle. We have a get current price reused out of one of the applications that I can't see right now. But here it is, reused out of the Forex trading application. So we can see that we only built half of our new application, therefore saving around 50% of the cost of development. Of course, it's not quite 50% because you still have to build the integration with the web services, but there's an immense cost saving. The risk that you face with the move towards SOA is one of ensuring the need to ensure loose coupling. If you don't ensure that the consumers of your services are loosely coupled to the applications from which they're consuming services, then any change to that application or the interface of the service or the location of the service or the policies that are enforced at the service will immediately break all the applications that are consuming that service. And that could be an immense cost and risk to the business. So that ensuring loose coupling is the critical challenge in deploying SOA. And that is one of the things that SOA infrastructure does for you. So let's look at a definition of SOA infrastructure. And this isn't my definition. This is a definition from Gartner, specifically from Frank Kenny and Darrell Plummer. Gartner terms SOA infrastructure as a web services framework. What that includes is a set of building blocks that all combine and integrate with a governance framework. So the components are a registry, repository, and those are two different things. A registry in an SOA world is typically a UDDI-enabled database. It's a place where you store core information about the services. And UDDI has a very strict data model and structure that defines what you can put in a UDDI registry and what should be there. And essentially it allows you to categorize services and provide a repository where a potential user of a service can search for a service that does a particular thing and find the service that's applicable. And then from information stored in the registry, they can determine how they're going to use that registry. The repository, on the other hand, is a broader term. And in our world, in the SOA infrastructure world, the repository is really a policy engine, a policy store. It's a place where you define and manage policies that are then associated with the services stored in the registry. So the two are definitely integrated and interlinked, but they're not the same thing. You also have a security fabric. So security provides the usual auditing, authentication, authorization, privacy, non-repudiation of service requests. There are many different ways of providing security solutions, and we'll cover that in a little more detail. Integration and transport, functionality that would now be generally thought of as being part of an enterprise service bus. So how do you ensure that messages coming in over one transport are routed over another? How do you transform message content to ensure version compatibility? Those types of things. Development tooling. Development tooling includes all of the toolkits and SDKs that you'd use to ensure loose coupling between a service provider and the consumer of the service. The whole concept of WS security libraries, all of that sort of stuff. Workflow and orchestration. I diverge a little from Gartner here in that I don't really believe that an orchestration solution should be part of your SOA infrastructure. I believe that an orchestration solution is an application that will consume and expose web services, but it's not really an infrastructure solution in and of its own. And then finally you have a management solution, and management is the concept of monitoring for performance and availability, service level compliance, and routing and transformation to ensure compliance with service levels, throttling, denial of service, all of those sorts of capabilities. Let's look at how that would work and how this stuff layers into a typical communication path. I think it's easier to understand when applied to the real world. So if we think of a typical or a basic web service communication with a client application. The client application will statically bind, which means it will have hard-coded information about the location of the web service and the interface parameters of the web service. And it'll invoke a request, send a message to the web service, and wait for a response. The web service will send back a response to the request. Now this is great, but what happens when the web service moves? What happens when you need to layer in security and all those sorts of things? So let's look a little more at that. So first of all, let's say we add a security layer. So we add an authorization and authentication framework around the web service. So now the web service is going to require that messages sent to it contain a SAML assertion. And maybe it will require that SAML assertion is generated or is authenticatable by a NetTegrity SiteMinder environment or an IBM Tivoli Access Manager environment. Sorry, I should have said Computer Associates SiteMinder. in order to ensure that the message that's coming into the web service complies with these security requirements, the client application is now going to have to implement a security layer where it will use some kind of tooling to ensure that the messages that it sends contain the appropriate SAML assertion. That the web service is then going to authorize the user that's encapsulated within that assertion to use the service. There's a whole bunch of other security requirements around signature encryption. So maybe the web service will require that a certain element of the message be encrypted, in which case the security layer at the client application will have to ensure that it is encrypted. Maybe the client application will sign the message so that the web service can verify the content of the message as it receives it. A number of complex capabilities that need to be added both at the service and the client layer. Step 2, what happens if you change the service? Even something as simple as changing the location of the service. That requires delegation at the client layer. You need to add a delegate layer so that the client application can discover the location of the service in real time and can dynamically make changes. Now, location is but one example of a dynamic change. What if the web service makes a dynamic change to the policies that drive authorization or authentication, or makes a dynamic change to the policies that drive encryption or signature? The client application needs to know at all times what policies will be enforced at the service so that it can ensure that messages it sends comply, and it'll use the delegate layer to do that. So the delegate layer should be able to discover policy and service location from a central repository, typically a registry, and make those changes or ensure that its messages comply with those policies. Now we start adding visibility. So as soon as you delegate, you need to ensure that you know who's contacting which service and why, how those services are performing, how reliable they are they complying with SLAs. So you add a reporting layer. You start capturing data at the service and reporting that back to a reporting database. Again, this logging monitoring layer needs to understand what its policies are, so it will communicate with the registry to determine what logging and monitoring policies it has to comply with before dropping data into the reporting database. At this point, you start needing an administrative interface so you can manage the data that you have for your delegates and your reporting. It's starting to become quite complex. The next step then is policy. So we've talked about security, we've talked about management, we've talked about reporting. All of this needs to be governed by a central policy management infrastructure where policies are enforced at the service and implemented at the client. And that's what a policy management enforcement layer comes in. So it's not overly complicated. You have a registry, you have a policy store, you have a database for reporting managed by an administrative interface. You have a delegate, you have a security layer, you have a policy management layer, both at the client and the server. And this is okay, but the problem really comes when you start repeating this for each and every single implementation of a service that you have anywhere. All of a sudden you have an enormous amount of code to maintain. It's conceivable if you're using different implementations to drive your policy, your logging, and your authorization, you might have 3 separate intermediaries deployed with every web service. It quickly becomes unmanageable and impractical. And that's where you need a consistent SOA infrastructure solution or SOA management solution, which is what our SOA software service manager provides. We're going to talk in a little more detail about exactly what service manager is, but while we have this diagram on the screen, I want to talk a little bit about some of the standards. So we talked about registry. Core standard for registry is UDDI. So the concept here is that a policy implementation engine or a policy enforcement engine will use UDDI to talk to the registry to discover the location of its policies. It'll then retrieve those policies from the policy store using an appropriate protocol. Policies are likely to be returned to the enforcement point or the implementation point using or in a format known as a WS policy assertion. Right now, there aren't as many WS policy assertions as we would like. The only standardized one is WS security policy. but we're working with the standards bodies to define more, and a number of vendors are cooperating on the definition of more policy assertion types. So in our world, you have central policy definition, distributed policy implementation, and distributed policy enforcement. And policy enforcement can either be as an agent or a proxy sitting wrapped around or in front of every single service instantiation that we have. So, where did my slide go? There we go. So SOA Software's products have won several awards. There's a few more pending at the moment. We were a 2004 Product of the Year, 2005 Network Computing Well Connected Award finalist. We were anointed by Gartner as a 2005 Cool Vendor and by Loosely Coupled as a 2005 Web Services Management Leader. We're certainly one of the most respected vendors in the SOA management space, as we should be. We have 4 products that combine to provide a comprehensive SOA infrastructure. We have Service Manager, Registry, Xml Bpm, and Solar, with Registry sitting at the core of SOA. Registry is an interesting story for us. We believe that registries will be ubiquitous. They're becoming close to ubiquitous in organizations with SOA deployments today. And we also believe that registries will be provided to large organizations as part of the SOA platforms that they deploy. So it'll come with your WebSphere platform, it'll come with your BEA tooling, it'll come with an Oracle environment or a Microsoft environment or a Sun environment. In much the same way that LDAP directories became ubiquitous in the late 90s and early 2000s as an underlying repository for identity management, UDDI registries will become ubiquitous as an underlying repository for SOA. Now that said, we continue to provide a UDDI registry because our other products require a registry to work. Unlike some of the other vendors in the space who synchronize between their own proprietary central database and the registry, we don't have any central storage for services other than the registry. So we leverage the UDDI registry as the sole central engine, in much the same way that a product like CA SiteMinder or IBM Tivoli Access Manager would leverage an LDAP directory. We leverage the registry directly. Synchronization doesn't provide an efficient or scalable model and leads to some severe problems. So the direct integration is definitely the way to go. Because of our other products' dependency on the registry, we continue to offer registry in the market, but we encourage our customers to work with existing vendors for registry, and those vendors include folks like Systernet, now a division of Mercury, or Flashline, or Logic Library, or Infravio. There's a number of players. IBM is entering the registry market, and we'll have a very solid offering out of the WebSphere group. And Oracle is moving into the registry game. BEA is announcing registry products. So there's going to be a wide variety of registries available, and as long as they comply with the UDDI v3 spec, we'll be able to work with them as a central repository. Service Manager is our flagship product. It's been in the market since 2001, first release, and we're about to put version 3.1 in the product. We have over 75 customers for Service Manager now, including large organizations like Verizon and Merrill Lynch. Service Manager provides the infrastructure for inside the firewall SOA management and security. Very powerful security capabilities, policy-based authentication, access control, a built-in public key management infrastructure. Change control, lifecycle management, so service discovery. We can discover a service that's deployed into an application server and can automatically manage it using default policies and alert the administrators that a new service has been deployed. We have approval processes, service versioning. We ensure the reliability and quality of service by monitoring SLAs and and discovering or determining through thresholds when an SLA is about to be violated, and then we can use throttling or routing technologies to dynamically adjust routing in the infrastructure to try to ensure that that services always comply with their service level agreements. We have provisioning management, configuration management capabilities where we can describe, configure, and manage services, and then the performance monitoring, notification, SLA, charting, all of the things you'd expect, as well as providing a comprehensive auditing infrastructure. XML Bpm is a B2B web services security product. It's not an XML firewall. In fact, it explicitly does not provide XML firewall capabilities. In the same way that in the IP world you have an IP firewall and then an IPsec or SSL VPN, we believe that in the web services world you should have an XML VPN along with your XML firewall infrastructure. The XML firewall is designed to keep the bad guys out, whereas XML VPN is designed to make it easy for the good guys to get in a secure way. So it really provides access control, provisioning, workflow-based offering mechanism to offer services to partners, comprehensive policy management, remote service virtualization to allow you to make it appear to your partners that your services are deployed inside their network, so they make local calls to a local proxy that then handles all of the security for interaction with the services at your end. It's a very powerful solution that's, again, widely deployed inside Fortune 100 organizations. Solar is a relatively new product for us. We announced in December the acquisition of some technology from Merrill Lynch. Merrill Lynch had spent several years building what it called X4ML as an internal CICS web services solution. Merrill Lynch, in fact, had looked at other solutions on the market and had concluded that they didn't meet its needs for scale, performance, and the type of development environment they required, so they built their own. It's an excellent solution, and we're very excited to now to own that and to have hired the team that builds it and to be offering that to the market. It's basically, its core differentiation from a lot of other products is that it's the only product out there designed for mainframe programmers. So it provides a mainframe-based runtime with a mainframe-based directory of services and then a web browser-based development environment for sort of point-and-click exposing of CICS applications as web services. It's a very powerful technology that's been extremely well received by customers. This diagram shows how the various products fit together. We covered a lot of this on an earlier slide, but essentially Service Manager provides the central policy definition infrastructure, leveraging a registry, either ours or a third-party registry such as Mercury or Infradia or Logicline, Reflashline, or IBM. Service Manager also includes distributed management points that are deployed either as agents inside the container, .NET or most of the Java app servers, or as a standalone proxy. Agents have the advantage that because they're wrapping the service directly, there's no other way to get to the service than to go through the agent, so they provide guaranteed last-mile security. Proxies are valuable because they can route. Clearly, once you've got to the agent, you're essentially already routed, so routing is really not much of an option. So a lot of organizations tend to use a combination of proxies for routing, dynamic load balancing, all those capabilities, and in-server, in-container agents for last-mile security. Solar, the mainframe web services product, also looks to the Service Manager like a management point. So it enforces policies discovered from the Service Manager, and it reports usage information and performance information back to Service Manager through standards like Wisdom, the WS Distributed Management Standard. XML Firewall also appears to Service Manager to be a policy enforcement point, enforcing and implementing policies defined centrally and reporting usage data back. And then finally, we have our gateway. The gateway is an SDK that provides consumer-side tooling to ensure that that consumers are complying with policies that will be enforced at the distributed endpoint. So what I want to do is talk a little bit about Verizon, specifically about Verizon's IT Workbench environment. IT Workbench has a fairly interesting genesis. And the Verizon basically looked at its organization in 2002, and at a C-level inside the organization, it realized that it had at least two of everything. Now remember that Verizon was formed as a merger of GTE and Bell Atlantic, so it's not surprising that it had two of everything. What was surprising, I think, was the number of some things that it had. It found that it had more than 50 deployments of certain types of applications and environments. So in order to embark on a massive cost-saving exercise, the CIO instructed his chief architect, a guy by the name of Shadman Zafar, to aggressively drive the organization towards service-oriented architecture. Now, this is the point at which Verizon made some very smart decisions. First of all, Verizon recognized that in order to succeed in a move towards SOA, it needed to do two things. It needed to provide tooling to facilitate the move to SOA from the architecture and development perspective, but it also needed to provide incentive organizationally to move towards SOA. So Verizon, on the process side of things, implemented a fairly rigorous architecture review committee type concept where any new application has to be reviewed by the architecture review committee and has to be verified and validated that it meets SOA requirements. Particularly, what Verizon does is ensure that any architect bringing a new application for approval to the architecture review board has to ensure that all of the components of the architecture that it's proposing require new build, and that none of them already exist. If there's something that the architect wants to build that already exists, then the architecture review board is going to say, no, you can't do that. We already have one. You need to use the existing thing. So that drives reuse. Also, organizationally, Verizon ensured that most of its IT management have reuse objectives. So in order to meet their management by objective criteria, they have to be able to meet certain reuse metrics through the organization. So those two things serve to help drive reuse through Verizon's organization. From a technology perspective, Verizon created what it calls IT Workbench. IT Workbench is a lot of internal development at Verizon, building portal technology, implementing a lot of SOA software technology for the SOA management and security infrastructure. The easiest way to understand Verizon's IT Workbench is to sort of walk through a typical example. Basically, IT Workbench provides a portal for developers and architects to use. In a typical model, you might have a developer of a service creates a web service and then needs to make that available broadly to potential users. So the developer will go to IT Workbench and will work through a wizard for publishing that service. And the wizard's going to ask a bunch of questions about the categorization of the service, what type of application it is, what it does, what its security requirements are, what its likely performance is. And at the end of that process, it'll instruct the developer or the architect to download an agent and deploy that agent along with their application inside the application server. And that agent will then ensure the security of the application and will monitor for performance and reliability. The flip side of that is a developer looking to use a service will go to IT Workbench and will discover a service by browsing through the registry. When they identify a service that they want to use, they then initiate a workflow to request access for their application to that service. And that workflow will go to the appropriate management and creators of the service, etc., for approval. Once it's approved, appropriate security permissions will be created, and the user will have access to that service. It sounds fairly simple, but it's a substantial undertaking that Verizon took on in 2002 and really brought to fruition in 2004 and 2005. With a very successful deployment. In fact, in the middle of 2005, Verizon was running between 2.5 and 3 million transactions a day, and you can see it was up from 10,000 transactions there at the start of 2004. Verizon estimates that it cut its IT budget by 50%, leveraging IT Workbench. Some examples of the types of transactions are customer information searches, requests for new service, credit history applications. Believes that it's reduced the duplication of resources from an average of more than 25 times. So Verizon's original estimate was that many resources would duplicate, well, that its resources, IT resources, were duplicated an average of 25 times, and that's now reduced that substantially. The first year that IT Workbench was deployed, it had a target of building 10 applications. It actually built 57. And by the end of the first year of IT Workbench's life, which was 2004, it had enabled more than 200 services, which is a pretty impressive achievement, and certainly not one to be overlooked. So with that, that's the end of the discussion today. Let me take questions and see where we go. So anyone who has any questions, please submit them through the WebEx panel, and I'll endeavour to answer them. I actually see that we have a few already, so let me take these on. Okay, so the first question is actually a very good one. They all are, of course. What is the difference between SOA and SOA infrastructure, and do these concepts overlap? Well, SOA, as I said earlier, is an architectural concept that provides enormous potential benefits to an organization. SOA infrastructure is the tooling that allows SOA to become real and allows organizations to realize those benefits that you get within SOA. So yes, the concepts certainly exist. Is there an existing set of SOA infrastructure best practices guidelines, or is this something SOA software offers? We have a services business, and we help organizations build SOA infrastructure best practices. It's certainly something that we do. It's also something a number of our partners do, and IBM Global Services in particular has a very strong SOA management practice that will help organizations with best practice guidelines and things like that. Okay, there's a good question here on very concerned with performance. How can I move to SOA infrastructure without slowing down too much? Performance is a good question, and I think one of the concerns that's raised with us a number of times by customers is, well, it seems that putting an intermediary in place or wrapping an agent around the service adds a bunch of latency and overhead to the execution of that service. Well, that's true in some circumstances. The baseline latency increase from one of our agents is typically in the order of a millisecond. And that's a very small, that's a tiny percentage typically. Now what you will see is that when we start encrypting and decrypting and verifying signature, that latency will increase, because we're now performing complex mathematical operations around the cryptography. One of the things that you have to realize there, though, is that cryptographic operation has to happen somewhere. So it's either going to happen inside the agent or it's going to happen inside the application server. And quite frankly, I would rather have that happen inside an agent that is designed to drive high-performance cryptographic operation than inside an application that's not necessarily architected and optimized for that. So we find that a solution like ours, which is optimized for performance, really really adds to the scalability and the performance capabilities of the SOA rather than hindering it. We have a question here about orchestration. From the orchestration perspective, are you executing steps that do not have dependencies in parallel to speed processing, or is each step executed one at a time? I'll assume that means that we're talking there about the execution of policy, so capturing usage information or encryption or decryption or verifying signature. The way our policy infrastructure works is that policies are defined as either a serial or a parallel type operation. So you can have a policy that has a set of serial operations. For example, you don't want to verify signature and take the expense of verifying signature if the request has already failed an authentication requirement. So some policy operations should happen serially, whereas others, such as signature verification, encryption or decryption, compression, that sort of thing, should happen in parallel. So we combine a sort of mixed mode world. Let's see. That's about it. Well, yeah, no, we've got some. Okay, we've got a couple more questions. One follow-up to the previous question on orchestration. Question actually from the business perspective, can component services be executed in parallel? Absolutely, but that's really outside the scope of the SOA infrastructure. The SOA infrastructure is ensuring the loose coupling of the service from the consumer, and an orchestration engine, which we don't provide. We do not provide a business policy management engine. The orchestration engine can certainly execute services in parallel. The orchestration engine would act as both a provider of services to the SOA infrastructure and a consumer of services from the SOA infrastructure. So it's really up to the individual business process orchestration engine as to how it operates in that world. Another question, how does one SOA enable a legacy world? That is what our Solar product is all about, service-oriented legacy architecture. And there are a number of other products in the market for web service enabling mainframes. Web service enabling a mainframe is sort of a two-way thing. In the case of our Solar application, it allows you to both expose CICS applications as web services and to enable a CICS application to consume a web service. So what you're really doing is allowing your legacy applications to participate in an SOA. If you think back to the late 90s, there was this frantic panic to migrate away from the mainframe. Y2K was approaching with this dread associated with it, and everyone was convinced that all the mainframe applications in the world were going to die as soon as year 2000 rolled by. Of course, Y2K actually sort of rolled by with barely a fizzle. What's happened since then is, I think, a realization that the mainframe applications are very stable. They're really quite inexpensive to operate. Those costs are very well understood. And that business logic has been working for a long time, so why mess with it? But that's in a context of a lot of new application build happening in a distributed environment. And so the need, there's a very strong need to ensure that the mainframe applications can participate and integrate cleanly with new applications, and that's where SOA really comes in. Instead of having to use expensive EAI technologies to integrate mainframe applications with the distributed world, you can use web services really very inexpensively. And we have a number of use cases wrapped around that showing how Merrill Lynch in particular has saved enormous amounts of money using Solar rather than traditional integration models. At that point, I think we're out of questions. I really appreciate you all taking the time to listen into the webinar today. We'll be making a recording available on our website, so please feel free to download that or send links to any colleagues or contacts that you feel may be interested in this. So, once again, thank you all very much, and enjoy the rest of your day. Thank you.